Okay, I'm going to do a few of these problems and go on the assumption that we did some of the beginning ones in class. I'm going to look first at a 45, 45, 90. Let's look at number 7. Okay, they want to know what x and y are equal. I'm going to look at this figure here, and I'm going to label it. Now, normally, when I have a 45, 45, 90, across from each 45-degree angle, I usually label it x, but they've already used x's here for their variables, so I'm going to choose a's, okay? So it's across from each 45-degree angle, that side length's going to be a, and then across from the 90-degree angle, it's going to be a square root of 2, okay? So that's so if I go do that, then let's see, across from 45 degrees, I'll call that a. Across from this other 45 degrees, we're going to call that a. I can see that x and y are going to be equal already because they're both equal to a, whatever that is. And then across from the 90-degree angle on the hypotenuse, that is a square root of 2. Well, I want to come down here and work a little bit. If you noticed, a square root of 2 is equal to 9 square roots of 2. So if you want to solve for a, all you got to do is divide each side by square root of 2, and the square root of 2's end up canceling out, and a is equal to 9. So everywhere I see a, I know that's going to be 9. So what I find out on number 7 is that x is 9 and y is 9 because they're both equal to a. You didn't really have to go do this solving down at the bottom. If you notice this, when I labeled that 9 square roots of 2 as a square roots of 2, you see that they both have a square root of 2, so a must be the number out front, 9. Now I thought we'd look at number 9. If you look at number 9, you've got a 30, 60, 90, and I have trouble writing that small, so I'm going to make a bigger copy of that problem. This side they call x, this side they call y, and this side they call 10. I notice the 30-degree angle is here, so that then the 60-degree angle will be over here. Most of the times they don't tell you both the 30 and the 60. They figure that you can subtract 30 from 90 and get 60. So most of the time they're not going to give you that much on a diagram. Okay, across from the 30-degree angle, normally I call that x, but since they already used x, I could use it here. I'm just going to go ahead and use a's to label. Across from the 60 degrees, that is a square roots of 3. And then across from the 90 degree on the hypotenuse, this is going to be 2a. Now, I label it. That's really my steps to doing this is I always redraw the figure, but you can mark up on the figure they've drawn if you want. But the very first thing you should always do is label. And then the second thing you should do is look for given side. There's only one side they're going to give me usually. That's the whole point of these, is that you only have to know one side. And so if I look, I can see that it's this one right here. 10 is equal to 2a. Well, if 10 is equal to 2a and I want to know what a is, I could divide both sides by 2 and find out that a is 5. So a is 5. That's what x is. So now I know that x is 5. Let me write that in black. X is, can't do it over there, can I? I'll just put it on the figure that I drew, and I'll write it in black. X is 5. Now, y is equal to a square root of 3, but I know that a is 5. We found that earlier. So if I substitute 5 in for a, it's 5 square roots of 3. So y is going to be 5 square roots of 3. So now we know what x is, and we know what y is. Okay? I figured we'd do one more 30, 60, 90, and maybe one more of the other type too. If you look at number 11, we have a 30, 60, 90. So I'm going to label with A's again just because I don't want to use X's and Y's. Across from the 30-degree angle, we call that A. I know that A is 12 because that side was labeled. In the process of labeling, sometimes you're going to go, oh, wait, there's what my main thing I got to find is. If I want to go ahead and finish labeling, because now I can find X and Y pretty easily, across from the 60-degree angle is this X. Remember how we label across from the 60-degree angle? It's a square roots of 3, and then across from the right angle, it's 2a. So if I want to know what x is a square root of 3. But I know that A is 12. We saw that right off the bat. We didn't even have to solve for it, so I just plug it in. X is 12 square roots of 3. Now y is equal to 2a, but we know that a is 12, so we plug it in. 2 times 12 is 24. So y is 24. And again, I'm not going to write those on that diagram because it's just too hard to get that on there. So now let's look at number 12. So on number 12, I'll use A's to label again since they've used X's and Y's. Across from the 45-degree angle, we're going to call that one A. Across from the other 45-degree angle, I'll label that A. And across from the 90-degree angle, I'll label it A square roots of 2. Do you see how both of this, with the 13 square root of 2 and the A square root of 2 right below it, both of them have the square root of 2, don't they? That means the number out front is my A. A is 13 in this case. And again, if you don't see that, you could say A square root of 2 is equal to 13 square root of 2, but this is very cumbersome, isn't it? If I wanted to solve for A, I could divide both sides by square root of 2. And on both sides, the square root of 2's cancel out, and I'm still left with A is 13. So A is 13. Oh, guess what? X was just A, wasn't it? And we just said A was 13, so X is 13. And Y over here was also equal to A, so A is 13, that means Y is 13. So we were able to find those pretty quickly. These type of problems are on your SAT, your ACT problems. They come in handy in trig and when you study the unit circle. So these are very, very good problems for us to spend some time on and make sure you get down well.